So hello guys, in this video we are going to solve this problem. So in this problem it is given that we have this integral and this integral is equal to a by sine alpha plus b. Then we have to find out the possible values of a and b. So let's see how we can do this. So this is multiple choice correct problem. So we have this integral. So in this integral you can see that we have this 1 divided by 1 minus cos alpha cos x, and the limit of the integral is 0 to alpha. Now what you can do, you can write this one as cos x by 2 whole square plus sin x by 2 whole square, and this cos x as cos x by 2 whole square minus sin x by 2 whole square. Now you can combine the terms of this cos x by 2 whole square and sin x by 2 whole square, and it will become like 1 minus cos alpha cos x by 2 whole square and 1 plus cos alpha sin x by 2 whole square. So now you can write this 1 minus cos alpha as 2 times sin alpha by 2 whole square, and this 1 plus cos alpha as 2 times cos alpha by 2 whole square. Now from here what you can do, you can take cos x by 2 whole square and cos alpha by 2 whole square outside. So 1 divided by this will become like this, sec x by 2 whole square sec alpha by 2 whole square multiplication, and here this sin alpha by 2 whole square divided by cos alpha by 2 whole square will become this tan alpha by 2 whole square, and here it will become tan x by 2 whole square. So now you have this half is outside, so this 2 factor will become half outside. If you take this 2 outside, this will become half, and you have this integral. Now in this you can assume tan x by 2 as t, so its differentiation is sec x by 2 whole square and multiply by half dx is equal to dt. From here you can write this as 2 dt, and you can replace this as 2 dt here. Here we have sec alpha by 2 whole square, and if you see the limits of previous integral, it is from 0 to alpha. So if you put x as 0, then t will become 0, and if you put x as alpha, then t will become uh, tan alpha by 2. So we have this thing. Here this tan x by 2 whole square will become t square, and here we have tan alpha by 2 whole square. So we have this. Now here this 2 factor will cancel, and we have this thing. Now this is a simple integral. This you can take outside, and this is 1 divided by uh, x square plus a square type of integral. So this integral is 1 upon a tan inverse of x by a. Here our variable is t, so it will become like 1 divided by tan alpha by 2 tan inverse t divided by tan alpha by 2. So this is simple integral, and the limit is 0 to tan alpha by 2. So you can put that. After putting, it will become like tan inverse 1 minus tan inverse 0. So this is pi by 4 minus 0. So the whole thing is pi by 4. And this 1 divided by tan alpha by 2 will become like cot alpha by 2, and this is pi by 4. This cot alpha by 2 you can write as cos alpha by 2 divided by sin alpha by 2, and this you can write as 1 divided by cos alpha by 2 whole square. So this will cancel, and it will become like 1 divided by sin alpha by 2 cos alpha by 2, and you can multiply by 2 here, and also 2 in the upper. So this will become like sin alpha, 2 is here, and this is pi by 4. So you have this integral is equal to pi divided by 2 sin alpha. So now if you compare with this a divided by sin alpha plus beta, a divided by sin alpha plus b, so you can say that a is equal to pi by 2 and b is equal to 0 is satisfying this. And if you put a is equal to pi by 4, then it will become this, and b is equal to pi by 4 sin alpha. Then this thing will become equal to pi divided by 2 sin alpha. So this is also matching with this. So you can say that this A option is also correct, and this B option where A is equal to pi by 4 and B is equal to pi divided by 4 sin alpha is also correct. So in this way, this A and B option are correct, and we can solve this problem.